Okay, so this is my final installment in this series of providing you the proof of these trigonometric rules. So we've already done the sine rule and the area of a triangle rule. This is the cosine rule. So this one is a step up from the explanations that we did for the sine rule and the area of a triangle rule. It's a little bit more complex to understand, and bearing in mind that you don't have to understand this stuff in standard maths too, you are quite welcome to just take this formula as the gospel truth and use it. So I'll go through the proof, but if you find this proof a little bit confusing, that's fine, because it is a little bit confusing, particularly given some of the things that we don't do in standard maths that would help make this make a little bit more sense. But essentially we've got the same situation as before. We've got ourselves a triangle ABC, and we've labelled all the sides A, B and C. For reasons that will become obvious later, I've put this little thing down the bottom to say that that length there is B, because I'm going to split that up a little bit. And I'm going to look to my side occasionally as well, because it is a little bit of a complex proof, so I've got it written down next to me, just so that I make sure I don't make a meal of it as I explain. So the very first thing we do, like the other two triangle proofs, is we just come along first and say, well, let's split our non-right angled triangle into two sides by making a perpendicular line from point B down to the base, thereby giving us two right angled triangles. And at this point, we're going to talk about triangle ABD. We're going to talk about this triangle in here. So there's a couple of things we're going to do in triangle ABD. I'll go with red today. So in triangle ABD. So the first thing we're going to do is we're going to say, well, actually we'll give some names to some spots as well. Now that we've got this, I'm going to say that this distance here and this distance there, I'm going to give them names. I'll just grab a ruler out and probably make it easy to do so. So we'll give these two distances some names. And I'm going to call this one here X. And this one here I'm going to call B minus X. So, in other words, the full length of the bottom of the big triangle ABC we created minus this length X that I've created. And then the final thing I'm going to do is I'm going to say that in here, this perpendicular line, I'm going to give it the length H, height of a triangle. H seems to make some sense. So therefore, in triangle ABD, well, D, where's D? You might add as well, this here is point D where we've made this line to, so that's point D there. Okay, so point D is there at the bottom of our right angle triangle. So the left-hand right angle triangle is ABD, and it has the sides C, H and X. So using then a little bit of Pythagoras, we know that x squared plus, sorry, I'll just make that a little bit clearer, x squared plus h squared is going to equal c squared. Using Pythagoras, x squared plus h squared equals c squared. And then I'm going to rearrange that a little bit. I'm going to, for reasons that'll sort of show up later, I want to express this in terms of h squared. So I'm going to say h squared equals c squared minus x squared. Now also in that triangle, I'm going to use a bit of right angled trig. And I'm just going to say that cos of the angle A is the opposite, is the adjacent over the hypotenuse. So that's going to be x over c. And I'm going to rearrange that again to say that in this particular case, if I multiply both sides by c, I'm going to end up with x equals c cos A. All right, and I'm going to give those two some numbers. I'm going to call that equation number 1. I'm going to call that equation number 2. I'm going to come back to those later on. I'm also going to pause the video here for a second as well. Now, at this point, we're going to switch triangles. We've got a bit of information out of that. We've got an expression for h squared, which might come in useful later. We've got an expression for x, which might come in useful later. But right now, I'm going to switch into this triangle here on the right-hand side. Didn't have my left and my right there. And so I'm going to say, well, now we're going to be talking about, and I'll change the colour here, we'll be talking about in triangle BCD. And for that, I'm just going to use Pythagoras again. So Pythagoras, obviously that a squared plus b squared equals c squared. In this particular case though, a is our hypotenuse, h is one of the sides, and b minus x is one of the sides. So what we end up with is a squared equals h squared plus b minus x squared. All right, because we've got b minus x is that length in the bottom of that triangle. So if I do a bit of rearranging there, another way to write this side would be h squared plus, well, b minus x squared is just b minus x times by b minus x. And then I can expand that out. If you remember from year 10, we'll do this a little bit later in the HSC, but we use a method, I use a method called the claw, or some people use FOIL, first, outside, inside, last. I always like to think of the claw. I draw my little lines showing where I've got to multiply, and it looks like a little claw. You can imagine, I'll just, wrong way. You can imagine a little claw there with the, there we go, with the red lines. So as I expand that out, I end up with h squared plus, well, b times b, well, that's b squared. B times by minus x, so that's going to be minus bx. Then we're going to have minus x times by b, that's going to also be minus bx. And then minus x times minus x is going to be plus x squared. And then I'll tidy this up just a fraction. And I'll say that I've got h squared plus b squared minus 2bx, because minus bx is minus 2bx, plus x squared. So there we go, I've got all of that information down. And the next thing we're going to do is we're going to remember equation 1 above. So I'm going to go remember equation 1. And what did equation 1 say? Well, equation 1 said h squared equals c squared minus x squared. Whoa, that's a terrible square. So what I can do now is I can say, well, everywhere I see a h squared in this particular line of working, I can replace it with a c squared minus x squared. So I'm going to end up with, well, h squared is going to be replaced with c squared minus x squared. Then I'm going to have b squared, I'm going to have minus 2bx, and I'm going to have plus x squared. And what's going to happen next is I've got minus x squared plus x squared, so those two are going to cancel each other out, and I can rewrite everything I've got so far as c squared plus b squared minus 2bx. Remembering, of course, this equals a squared. I'll just copy that down. I don't keep copying the left-hand side down, but I still know that a squared equals c squared plus b squared minus 2bx. Now, the next thing I have to remember is the other equation I created out of the other triangle. So remember equation 2. Well, what was equation 2? It said that x equals c cos a. So that means wherever we see an x in this particular equation, we can replace it with c cos a. So we substitute again, a squared equals c squared plus b squared minus 2b times by c cos a. Okay, and then it's just a little case of rearranging. I can write that out. So a squared equals b squared plus c squared minus 2bc cos a. Now that's slightly different, I think, than the version of the formula I gave you up above, which is c squared. Yeah, so the other one's expressed in terms of c squared. This one's expressed in terms of a squared, but you can see that the same basic formula applies. We've got the side that's opposite the angle squared equals the square of the other two sides minus 2 times by the other two sides multiplied by the cosine of the angle that we're interested in. So we've got the same basic formula, it's just expressed in terms of a squared instead of c squared. But that's how we get the proof for that one. Now, if that's a little bit foggy for you, that's fine. As I said at the start, this is not something that's compulsory. It's just for those of you that want to understand where these things come from, you can have a little bit of a look at that and understand. But in standard maths, we only really need to know how to apply it. That's the end.